SpaceX just became one of the most profitable AI companies on the planet, quietly, without a press conference, without a product launch event. Not from rockets, not from Starlink subscriptions, from computing power rented to the world's most powerful AI labs from platforms operating above the atmosphere. This is not a prediction, this is already happening. And when you understand the complete plan, from orbital data centers to lunar, factories to magnetic launch systems firing hardware into space, you will never look at SpaceX the same way again. Because the rockets were never the destination. They were always the vehicle for something far larger. For 60 years, humanity's reach into space has been funded by governments, by political will, by national pride and Cold War necessity. Apollo consumed what would be over $280 billion in today's money. It sent 12 human beings to the surface of the moon, and then it stopped. Not because the mission failed, because the budget did. NASA's Artemis program is facing the same gravitational pull, tens of billions spent. Timelines continuously extended. Political support dependent on election cycles rather than engineering milestones. Here is the structural problem that no one at these agencies will say out loud. Government programs are built on appropriations, not business models. And appropriations disappear when priorities shift. For humanity to build a permanent presence beyond Earth, not a brief visit, not a symbolic footprint, but actual infrastructure that sustains itself across generations, the economics have to work without a government check. Someone has to make space profitable. That responsibility has fallen to SpaceX. But here is the part that almost no one is discussing. Rockets alone will never generate the kind of capital required to build a civilization on Mars. The launch business, even at the scale SpaceX operates, is not a sufficient engine. SpaceX needs a fundamentally different revenue source, and it has already found one. In 2024, SpaceX merged operational elements with xAI, Elon Musk's artificial intelligence company, the creator of the Grok large language model. The move looked like corporate consolidation on the surface, a tightening of Musk's personal empire. The financial reality was something else entirely. Following the merger, SpaceX began operating advanced AI data centers housing hundreds of thousands of high-performance GPUs, the processing chips that power the training and operation of large AI models. Companies across the technology industry, from venture-backed startups to Fortune 500 corporations to research institutions, were desperate for that computing capacity. The revenue began flowing at a scale that stunned industry observers. Reports emerged that SpaceX was generating more income from renting AI computing capacity than from rocket launches and Starlink subscriber fees combined. Pause on that. The company that redefined aerospace, that built reusable orbital rockets and deployed the world's largest satellite internet constellation, was quietly becoming a dominant force in AI computing infrastructure. And it was doing so because it possessed something the rest of the AI industry was rapidly running out of: the operational scale to build data center infrastructure faster than anyone else on Earth. Except Earth itself is about to become the problem. Artificial intelligence is an infrastructure problem disguised as a software revolution. Every large language model, every vision system, every autonomous decision engine requires enormous volumes of computing power to operate. That computing power lives inside data centers, and data centers are consuming the planet's resources at a rate that no one in the technology industry wants to say publicly. By the end of this decade, AI computing infrastructure is projected to consume more electricity annually than many mid-sized nations. The land requirements are vast. The water demands for cooling systems are straining supplies in drought-prone regions. Local power grids are being pushed past their design limits by single installations demanding gigawatts of continuous power. The faster AI grows, and it is growing faster than nearly any technology in history, the more acute this resource conflict becomes. There is no clever optimization that solves this on Earth. The constraints are physical. Land is finite. Power grids age. Cooling costs rise with global temperatures. SpaceX's answer to this problem is not incremental. It does not propose a better cooling system or a more efficient chip. It proposes removing data centers from Earth entirely. Picture a constellation of satellites operating in low Earth orbit. Not imaging satellites, not communication relays, but computing nodes. Purpose-built to think. Each one a processing cluster, each one drawing power from direct, unfiltered solar radiation available around the clock without the energy losses imposed by Earth's atmosphere. Each one radiating waste heat directly into the cold vacuum of space, more efficiently than any terrestrial cooling system ever engineered. These orbital computing nodes communicate with each other through laser optical links, tight, precise beams of light that transfer data at speeds that make ground-based fiber networks look primitive. A request from a researcher in Sao Paulo routes up to the constellation. Processing happens in orbit. The result returns in milliseconds. The user never knows the computation touched space. The business model is structurally identical to cloud computing as it exists today. Rent computing time to AI companies the same way Amazon Web Services rents cloud capacity to enterprises. Except the infrastructure is beyond the reach of competitors, powered by free solar energy, and scalable across thousands of orbital slots without requiring a single square kilometer of Earth's surface. SpaceX is not starting from zero. Starlink already represents the most operationally sophisticated satellite constellation in history. The engineering pathway to orbital computing nodes is a proven capability extended to a new mission. But deploying it at scale requires a single critical tool that is only now becoming real. Starship is the most important industrial tool in human history that most people are still treating as a spectacle. Every orbital launch system that came before it, including SpaceX's own Falcon 9, was expendable or only partially reusable. That cost structure was not a technical limitation. It was a fundamental economic barrier that made deploying large-scale infrastructure in space financially impossible for any private entity. Starship is designed for full reusability, both stages. Returning to the launch tower for rapid refurbishment and reflight, operating closer to a commercial aircraft schedule than a traditional aerospace program. The cost per kilogram to orbit at full operational cadence collapses to a number that rewrites which space infrastructure projects are economically viable. SpaceX has already demonstrated catching the Super Heavy booster with the launch tower's mechanical arms, a technical achievement that would have been considered fantasy by serious aerospace engineers a decade ago. At scale, Starship becomes a supply chain, not a launch event. Hundreds of orbital computing satellites, deployed in batches, networked into a growing constellation. The rocket returns, reloads, and flies again. The rocket is not the product, it is the delivery mechanism. And once it reaches full operational tempo, the architecture expands to a scale that demands a fundamentally different frame of reference. Here is where the plan reaches its most structurally ambitious dimension. Launching everything from Earth, even with a fully reusable Starship operating daily, carries an inherent ceiling. Earth's gravity well is deep. Escaping it always costs energy, time, and mass. The planet itself is the bottleneck. The moon's surface gravity is 1/6 that of Earth, and the moon's crust contains exactly the materials needed to build orbital AI infrastructure: iron, aluminum, titanium, silicon, the raw inputs for satellite structures, solar panel arrays, thermal radiator systems, and computing hardware casings. The long-term architecture envisions a lunar industrial base, a facility on the moon's surface using autonomous robotic systems to extract local resources, process them into usable alloys and components, and assemble satellite hardware without reliance on Earth-based supply chains. The delivery system from the lunar surface into cislunar space is not a rocket. It is a mass driver, an electromagnetic rail system that accelerates payloads along the lunar surface to escape velocity using electrical energy alone. No combustion, no chemical propellant. Magnetic force applied along a track, powered by solar arrays operating in the continuous sunlight available at select lunar locations. A functioning lunar mass driver launches finished satellite hardware into space at a marginal cost approaching 0 per kilogram. Those units join the orbital computing constellation without ever touching Earth's atmosphere. The cycle then becomes self-reinforcing. Revenue funds manufacturing. Manufacturing reduces cost. Lower cost expands the constellation. A larger constellation generates more revenue. The system accelerates under its own logic. The numbers at the end of this roadmap are genuinely difficult to reason about using conventional financial frameworks. The global AI market is already measured in hundreds of billions of dollars annually and growing at compound rates that outpace almost every other economic sector. As AI becomes the computational layer of the global economy, embedded in healthcare diagnostics, logistics, financial modeling, materials science, defense systems, and climate research, the ceiling on demand for raw computing power is simply not visible. If SpaceX controls a meaningful share of orbital computing infrastructure as that demand compounds over the next 2 decades, analysts project that segment alone could reach valuations in the tens of trillions of dollars. That is not an exit, that is fuel. Fuel for a permanent crewed base on the moon, for the transit infrastructure connecting Earth to Mars, for the industrial systems that turn a red desert planet into something a human civilization can actually inhabit. Elon Musk stated publicly, years before any of this was technically credible, that the entire purpose of SpaceX was never to generate returns in the rocket business. It was to make humanity multiplanetary. The rockets were always means, not ends. AI infrastructure revenue is now the financial engine capable of driving that mission to completion at the speed the mission actually demands. Every great civilization is defined by the infrastructure it chose to build. Rome built roads that connected a continent and lasted centuries after the empire that built them was gone. The British Empire built maritime networks that linked hemispheres. The United States built the interstate highway system and then the global internet, technologies that transformed not just America, but the structure of the world. The infrastructure being built right now, node by node, orbit by orbit, will define the next era of human civilization in a way that none of those predecessors were able to anticipate. The story of space exploration has always been told as one of courage and discovery, of astronauts and engineers pressing against the absolute limits of what is physically possible. But civilizations are not sustained by inspiration alone. They are built on economic foundations, on systems that generate enough surplus to fund the generation that follows. For the first time in history, there is a credible path from here, from the surface of a single planet, to a species that lives, manufactures, and expands across multiple worlds. Not as an aspiration, as a business model. The fuel for that journey is not liquid oxygen and methane. It is computing power, rented from orbit, manufactured on the moon, generating the kind of revenue that turns the dream of Mars from a speech into a city. The timeline is already moving. If this video reframed how you understand what SpaceX is actually building, share it with someone who still thinks the space race ended in 1969. Drop a comment below. Do you believe orbital AI data centers will be fully operational within the next 10 years? The debate down there is worth reading. And if you want to stay ahead of the technologies quietly reshaping civilization before the rest of the world, notices, subscribe now. A new documentary drops every day. The next one goes even deeper into the infrastructure being assembled right now to support permanent human life on Mars. The future is being built faster than the news cycle can track.